In this video, we're going to look at some more questions involving trigonometric equations, which may involve the addition formula or sometimes the double angle formula. So let's take this question here. It says to solve for cos theta minus 30 degrees equals 8 root 2 sine theta in the range where theta is greater than or equal to 0 but less than or equal to 360 degrees. And each answer should be rounded correct to one decimal place. So we could start off by using the addition formula for this, and you should be aware that cos A minus B is exactly the same as cos A cos B plus sine A sine B. So we're going to use that here to expand this bracket. So it's going to be 4 lots of cos theta cos 30 plus 4 lots of sine theta sine 30. Now that is equal to 8 root 2 sine theta. I'll just improve the clarity of my handwriting there. So it's 30 degrees. So now we can use some exact values. So for cos theta will stay the same, but cos 30 we know is root 3 over 2. Then we have plus 4 sine theta, and we know that sine 30 is a half. Now all of that is equal to 8 root 2 sine theta. So simplifying that down, we get 2 root 3 cos theta plus 2 sine theta is equal to 8 root 2 sine theta. So what I'm going to do here is divide throughout by cosine theta. So let's divide all of that by cosine theta. Let's divide all of that by cosine theta. Let's divide all of this by cosine theta. And what we get is cos theta divided by cos theta just gives me 1. So 1 times 2 root 3. That's going to give me plus 2 tan theta equals to 8 root 2 tan theta. So I'm going to bring all the tan theta terms on one side. So I'm going to get 8 root 2 tan theta minus 2 tan theta is equal to root 3. Now we can factorize tan theta out to give me 8 root 2 minus 2 is equal to 2 root 3. So we can then say, making tan theta the subject of that equation, tan theta is 2 root 3 all divided by 8 root 2 minus 2. Now we can arctan that. So theta is going to be arctan of all of this. So we're going to get our calculators out now in a minute. Don't forget to round our answer to 1 decimal place. And what we get on our calculator is 20.4 correct to 1 decimal place as our principal angle. So now we're going to use the cast diagram. So we're going to draw the cast diagram here and say in which quadrants is tan positive. Well, it's positive in the first quadrant, so we can write 20.4 here. And it's also positive in the third quadrant. It's very important at A level you know how to use the cast diagram properly and efficiently. So we always measure angles in an anti-clockwise motion, so it goes from here to there. So the second solution is going to be 180 plus 20.4. So 180 degrees plus 20.4. So theta so 20.4 plus 180 gives me 200.4 degrees. So we can say our solution set. This is how you show full thorough working out in your working out. So our solution set is followed by a colon, theta, and we list the solutions. 20.4 degrees, comma 200.4 degrees are our required solutions. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we need to solve 3 cos theta equals to 2 sine theta plus 60 degrees in the range of 0 to 360, given your answer to 1 decimal place. So notice we've got theta plus 60 degrees. So what we're going to do now is expand this so that we're going to write the identity for sine A plus B, or the addition formula for it, which is sine A cos B plus cos A sine B. So what you get here is 3 cos theta is 2 sine theta cos 60 degrees plus 2 cos theta sine 60 degrees. So as we did in the previous example, we're going to write the exact values in. So we get 3 cos theta equals 2 sine theta. Now cos 60 is a half, so we're going to write that in. Plus 2 cos theta sine 60 is root 3 over 2. And then what we get is 3 cos theta equals sine theta plus root 3 cos theta. So then, like before, we're going to divide throughout by cos theta. And then we get 3 3 equals tan theta plus root 3. So from here, we could rearrange for tan theta. So tan theta is 3 minus root 3. We can arctan that now. Don't forget, arctan is the same as tan inverse. Get that from our calculator. And that gives me 51.7 to 1 decimal place. And now we're going to use the cast diagram for that. So let's draw a cast diagram here. So where is tan positive? It's positive in the first quadrant, so 51.7 degrees there. And it's also positive in the third quadrant. So ASTC, and then we go from here all the way to there. So our second solution is 180 degrees plus 51.7. So we can type that here on our calculator, which gives me 231.7. So 231.7 degrees. So we can say, therefore, our solution set is then theta is equal to 51.7 degrees followed by 231.7 degrees. Rounded correct to 1 decimal place are our solutions.